Today is a good day. I finished this book. I read it almost cover from cover. And usually I don't do this for this kind of books, but it was the first book on real-time ray tracing, and I kind of decided to read it all. But I spent a lot of my free time, probably more than a year, to do this. And now I'd like to do a quick review, just go over the table of contents and talk about each chapter. Here I use this check mark if chapter is good, and this wavy mark if chapter is average, and this line here if I skipped chapter because I kind of was not very interested in it. And yeah. Okay, chapter 1, ray tracing terminology, is kind of introduction to some terminology. It was by Peter Shirley, and everything by Peter Shirley is great. Chapter 2, what is ray? Its definition of ray and how it's represented. And it's also by Peter Shirley, so by definition, it's also great. Introduction to DirectX ray tracing. It's about graphics API. It's not kind of real graphics, more like system graphics, but it might be interesting, yeah, if you don't know about this. Chapter 4, Planetarium Dome Master Camera. I think it's how to stop some non-standard camera and ray generation, but I skip it because I wasn't very interested in this topic. Chapter 5, Computing Minimum Maxima of Subarrays. It's not exactly about ray tracing, but it was interesting. Yeah. Then part 2, Intersections and Efficiency. Chapter 6, a fast and robust method for avoiding self-intersection. And this chapter is really great. It's how to fix some precision problems that, that happen when we use math in computers, but it balances simplicity and efficiency of this approach. So it solves most problems, but is very easy in implementation. There are kind of other approaches that involve a lot of computations and some hardcore estimates, but it's really good. So chapter 6 is really good, and I already use this method in my offline renderer. Chapter 7, how to properly intersect sphere. It's good chapter, good to know, and some things about also floating point numbers. It's also fascinating, the stuff. Chapter 8, it's probably a good chapter, but I skipped it. I read some of it, but I skipped most of it. Chapter 9, multi-head ray tracing. It's actually, to be honest, I don't remember all of it. Probably when ray hits multiple object or something like that. I read it, but I forgot, and it was so for me. I remember that, but I remember that chapter 10, it was great, because when we retrace something complex on GPU, we need kind of to properly schedule and load balance work, because different regions of the image can have completely different kind of performance requirements and computing requirements. Describes how to do this properly. And part 3, automatic handling of material in nested volumes. It's when you have a glass and or when you have water, and in the water you have water in the glass, and in the water you have ice, and in the ice you have bubbles, and you have a lot of refractions, and it describes how to handle all this complexity in automatic manner. To be honest, there is other approach, some more old style, and it is not automatic, and it is uses manual assignment of priorities. But I think I like it more, and it's also used in some offline retracers like Arnold. Okay, next chapter, microfacet-based shadowing function to solve the bump terminator problem. It just solves some problem related to using shading normals, because shading normals, it's not, strictly speaking, physically a real thing. It's something we added to make computer-generated imagery look better, and fix some artifacts. And it's a good chapter. I think I didn't like some approximations they did, because they tried to say that they use kind of physically based distribution functions or some known distribution functions, and then derive result from it. But I felt that you can start almost with anything if you need to come up some empirical kind of result. There is another paper from Disney, and I like it more because they from the beginning say, okay, let's just come up with some empirical thing, and then we'll check if it solves our problem. And I think they are more honest. Okay, so next, ray traced shadows. I think it was between great and medium. I'll be nice today. Yeah, it's how to do ray traced shadows, maybe a bit heavy, because yeah, it's an entire pipeline related to shadows, but okay. Then it's about acoustics in water, and I skipped this chapter because if you are interested in this topic, it's probably great. It's very detailed thing. Also, I'm not sure if it's very performant or not. Okay, but the next chapter is for sampling, and a lot of chapters from this chapter is about Math-FAR. So by definition, all these chapters are great. The writing is great, the theory is great, and to be honest, kind of this games series often they introduce some final result, but often they lack some underlying theory, so you need kind of to read that in other places. And it's good to have some basic introduction kind of to the topic. And this chapter is about this basic introduction, in this case, introduction to sampling. So they're great. Even if I read about such topics before, it's always good to refresh your memory, because not all neurons are there, and yeah, it's good to redo all connections. Yeah, so it's about sampling. It's great stuff from Math-FAR. It's very nice. The last chapter, I think, is not from Math-FAR, important sampling of many lies on GPU. I don't remember exactly what it's about. I think it's about when you have many lies, so you need kind of to sample them, and to select some lights randomly, like for example in offline renders, like some cartoons have zillions of lights, and yeah, you need still to sample them. And yeah, I have impressions that I like it in the beginning because everything makes sense, but in the end I was a bit disappointed. Maybe performance was not great according to them, and they did mention that at the beginning, or maybe it was not about this chapter, but yeah, I think it was average. Yeah, average and almost great. Yeah, denoising and filtering. It's chapter 19 about Unreal Engine 4. Yeah, it's how they added ray tracing to Unreal Engine. I believe a large part is about how they did refactoring of the code base to be able to edit, and kind of, yeah, some nice stuff. Yeah, Unreal Engine, it's nice stuff, but chapter 12, it's great stuff, because yeah, in the rasterization we compute texture level of detail automatically, so GPUs do this for us, but we should do something about this in ray tracing, because yeah, it's a bit tricky, and standard approach in offline rendering is to use ray differentials, but it might be a bit costly. Actually, in my sample demos I used ray differential, but the chapter introduced some I believe ray cone tracing. So yeah, it's a bit more simple approach, but still it produces good result, and it's very good. It's very good to know this thing, how to do this properly. And I believe in chapter 21 they apply that ray cones approach from chapter 20, how to use some filtering in practice, kind of to sample from environment map. And chapter 22, it's how, I believe it's when some anti-aliasing techniques fail in some cases because they don't have all information, some disocclusion. Yeah, we can use ray tracing kind of to fix those edge cases, and it's how to do this. And part 5, interacting light map and irradiant volume preview in Frostbite. This chapter describes only preview stage. It's not kind of what happens in real time, but they generate light maps, and they have solution how to preview them in real time. So when they change camera, they redo all past tracing, and they past trace in, and yeah, they have caches to speed up the rendering. So the artists have ability to preview past trace results at interactive race, almost maybe real time in the editor. Yeah. So it's good to know that you have some to know approximate final result before you press some button and start some render farm for a few hours. And chapter 24, real-time global illumination with photon mapping. Oh my god, I know I read this chapter, but why don't I remember? Why don't... Let's check specific page. 409. Yeah, I know I don't have tripod right now, and it's inconvenient, yeah. But it's not the biggest problem. I can't hardly speak English, so it's a bigger problem right now. What is about? Yeah, I see it's about some advanced photon mapping. Okay, I read this chapter, but for some reason I don't remember everything. Yeah, I think it maybe it's not bad, but I put it average. Then hybrid rendering in real-time ray tracing. Yeah, I think the truth that I don't have good memories about these hybrid rendering chapters, but although I read them all, but this chapter was good. And deferred hybrid ray tracing, yeah, I remember it was also not bad. And yeah, chapter 25, I think it's about how they dynamically generate surface information, so there is no precomputation, and also surfaces can serve as cache to store this already results of ray tracing, so it can be reused. It's pretty good. But I also like this, I very good remember this chapter 27, because it's not from it's a bit from different industry, not from game industry, and it's great how to do this for scientific computation, and how people from that area have a bit different background. Also, it's written very well, probably because some experience in academic field, so those people are pretty good in writing. And chapter 28, retracing in homogeneous volumes, it's a very good chapter. It's very short, but it introduces Woodcock tracking, and it explains this very good. Yeah, very good introduction. So I actually understood it, how it works. But I didn't do any volumetric rendering before. Yeah, So even for people like me, it explains things very, very good. Efficient particle volume splitting in the ray tracing. I've looked through this chapter, but yeah, mostly I skip it. It's when we have a lot of particles and we can kind of something to sort it along the ray and kind of do almost proper blending. And yeah, with ray tracing, it allows to do this kind of to render more particles that then you can do with rasterization. But yeah, I don't have a good opinion about it. I skipped it almost entirely. Caustics using screen space photon mapping, and I have special remark about this chapter because obviously it is written by a guy for whom English is not native language the same as for me, and there are a lot of typos and it's a bit hard to read, but the chapter is really great. It shows how to apply photon mapping kind of in the form as it was kind of almost in the same form as it was originally described in 2002 by Jensen. And yeah, so it's mostly you trace photons and then use, but you store the results of those photons not in some 3D complex 3D structure, but directly in screen space. Yeah, and then apply those results directly after filtering to final image. So yeah, it's maybe a bit heavy, but it's not super heavy. So for example, maybe in modern GPUs, kind of 3000, it will work better. But I like that this chapter is written in some more honest way. So it explicitly say if something doesn't work or if there is some problem, it explicitly mentions about that. And yeah, it's really good. I wish the editors of this book made better job into editing this chapter to have better English, because material is really great and it's really good chapter. And chapter 31, variance reduction via footprint estimation in the presence of past reuse. This chapter will be very useful for people who worked before with rendering technique called VCM, vertices connection and merging. It's kind of, you have path tracing that you can extend it with bidirectional path tracing to handle more cases, or then you can use photon mapping to have even more kind of acoustics and things like that. But VCM handles even more cases, and it adds some improvements to VCM, so it's good. I don't know much about this topic. And the last today is very sunny. You've seen how shadows, how ray tracing, it works great today. And the last chapter is accurate real-time specular reflections with radian caching. It's pretty big chapter and a bit complicated. Actually, it describes how to calculate glossy reflections. So, I mean, to calculate glossy reflections, you need to calculate integral. So you need to sample along for specific pixels to shoot many rays and kind of estimate integral with Monte Carlo. And this chapter describes how to do this in practical way. So they use caches, and yeah, a lot of information is cached, so you don't need to trace rays in all cases. But I feel it's a lot of limitation, and it's mostly maybe for demo purposes. So it mostly kind of for static geometry does handle well the dynamic stuff, and it still has a lot of details, and it is a bit costly. So it works well for things like Sponza, but even for Sponza, it on the limit of 2080 GPU. Yeah. So it was I put it maybe pretty good. It was pretty good because it's the last chapter, and also authors did pretty good job at explaining technique. Yeah, so that was it. I think that 66% of this book are great chapters, and 32% are average chapters that you might skip, and maybe there are 2 or 3 chapters that are bad, not very good written. And yeah, thank you. Bye.